Good morning, good afternoon, good evening. My name is Thomas Burke. I'm the Global Director of Industry Standards for CLPA America. And I also have Mariana Alvarado, who is our marketing specialist for CLPA America, taking care of Mexico, on the line. We appreciate everyone taking time out from their busy day to talk about TSN and our game-changing technology, which we believe is really transforming the smart factory. We will be putting together kind of a frequently asked questions as we go through the technology, and that will be available off of our website that we'll talk about later on. Mariana, I'll turn it over to you to start the presentation.
Thank you, Tom. Well, thank you for joining and welcome to the webinar. As Tom said, we will talk to you about the use and development of the TSN technology and particularly about CCLink IATSN. The evolution in the industry automation technologies has led us to the conclusion that to really have a smart factory, we must seek for the convergence between IT and OT, and this convergence and communication has to be efficient. So time-sensitive networking, or TSN, is the foundation of high-speed deterministic data integration that is truly necessary for the smart factory to become a reality. So TSN actually started as the Ethernet technology for audiovisual industry, which needed a high-speed mechanism that was deterministic and reliable for video streaming. So that's how the technology of TSN started. But first, before we get more into TSN, I would like to explain what is the relationship between Mitsubishi Electric and CLPA. Mitsubishi Electric developed the CCLink technology as an exclusive protocol for its automation products, but with the need that the products of different brands were able to communicate, in 2000, Mitsubishi released the CCLink to the public domain as an open network. In the same year, the CCLink Partner Association, or CLPA, was formed to manage the CCLink network technology family. The main activities and services that CLPA develops, it's manage the CCLink family networks, the protocol specifications, provide technical and development support to members, conduct CCLink educational seminars, provide CCLink conformance testing for member products, participate in trade shows, trainings, and other activities, for example, PAC Expo. And as you can see in the pictures here in Mexico, we participate in this kind of activities with Mitsubishi Electric, hand by hand. And finally, promote and market CLPA products via trade shows, publications, seminars, social media, and World Wide Web. So what is the strategy of Mitsubishi Electric and CLPA to get IT and OT to communicate with each other, even if they are very different worlds? Well, the strategy is called eFactory. This is about breaking down the barriers between these two worlds using CCLink IE family networks and Mitsubishi products to optimize manufacturing by connecting all the devices and equipment, no matter what layer they belong to. If they belong to IT or OT, it doesn't matter. And in that way, be able to collect and analyze all the information efficiently. eFactory Alliance is a strategy partnership with other best-in-class companies, so our customer can have a premium total solution. Well, now I will give control to Tom. He's going to explain more about TSN.
So today we're going to talk a lot about Industry 4.0. I want to talk about more detail about what TSN is and what is the CCLink IATSN and why Mitsubishi Electric really took to task and basically started adopting and bringing products to the marketplace with the CCLink IATSN technology. If you think about what's going on in the overall industrial world, there is what's known as Industry 4.0 that started off in Germany, basically focused at improving manufacturing. And they started looking at all the necessary standards, essentially, that people would use, particularly suppliers, to bring products to market based on the technology. They recognize that standards are very important, and one of the key standards that they have selected as part of the equation is the CCLink technology as part of Industry 4.0. Across the world, there's a lot of other organizations essentially that are doing similar things to Industry 4.0. So for example, we have Made in China 2025, which essentially is the Chinese version of Industry 4.0. In Japan, we have a similar organization, IVI, which is the Industrial Value Chain Initiative. And again, it's focused at making suppliers and end users have products that really work together, really focusing at the whole manufacturing computing. So when you think about this whole crazy world of the industrial Internet of Things, the edge, the fog, and the cloud, all of this really ties together with what a lot of the different countries and regions are doing that are based on a lot of this Industry 4.0 technology. In the United States, we have an international organization actually that's called the Industrial Internet Consortium, and they're working very aggressively at developing test beds essentially that proves the technology that allows the suppliers to develop products for specific cases, demonstrating how it works for the end users. And I'll talk a little bit more about that later on. In the Industrial Internet Consortium, the 3 test beds that are currently very active have to do a lot to do with smart manufacturing and what they've been publishing. One of the key technologies that they're doing actually is related to TSN and how TSN basically provides the whole concept of real-time control and synchronization of high-performance machines over a single standard commercially available Ethernet network, really supporting multi-vendor interoperability and data and information integration. This is why CLPA was rapidly developing the CCLink IATSN technology necessary to support TSN. So let's talk about what is TSN and how TSN really is a collection of the IEEE standards and why it's so important to our industry. So when I first started looking at TSN about 5 years ago, I attended a seminar and they were probably very focused at the audiovisual market, and they were also focused at how to put TSN inside of the automobile. I quickly recognized the opportunity that TSN could be a technology that we would actually use in industrial manufacturing. TSN is really a set of standards that is being managed by IEEE under what's known as the 802.1 working group. The TSN task group was actually formed in 2012. So if you take a look at it, was over 8 years ago. And essentially they were looking at how did they do time-sensitive transmission of data over deterministic Ethernet networks. And again, as I said, originally TSN was designed essentially for the audiovisual industry, where they were trying to move, essentially streams of data in a high-speed deterministic way, guaranteeing that the other side, the receiver, got all the information and got the information without losing any or having any gaps or breaks in the data or jitter. So specifically, when we talk about what are the real benefits of TSN and why I'm so excited about it, well, really it's a collection of standards under IEEE that's really grouped into essentially 3 different component categories that really define TSN as a complete communications system. The biggest things that really are being addressed in those different groups is the whole concept of time synchronization between machines and essentially guaranteeing that the clocks are all synchronized across applications and devices, the ability to scheduling of messages and guaranteeing reliable delivery between 2 endpoints, whether it's applications, whether it's devices, whether it's machines, essentially all on a commercially off-the-shelf Ethernet. The other thing we've done is it addresses the whole concept of traffic shaping, and I'll talk about that, and really fault tolerance is part of the key strategy of the TSN technology. Let me talk a little bit about the time synchronization aspect of TSN. Essentially, all the devices that are participating in real-time communication need to have a common understanding of time. And this is the whole time synchronization part of the architecture that TSN is addressing, such that every single device will basically be synchronized and will have the same time, and it's all with intercommunication between the different devices. So there's always the same common understanding of time, because this is very important when you start thinking about, scheduling applications, you start thinking about historical data and things like that. You want all the data to be relevant according to the same time. All devices, when I talk about scheduling, really are participating in real-time communication, and they really need to adhere to the same rules in processing and forwarding communication packets. This is the big thing that TSN is addressing, guaranteeing that all devices participate on the same understanding, such that there's no collisions and that the technology allows essentially for intercommunication and guaranteeing fairness across all of the messages that need to be sent out by the different devices on the network. One of the things that TSN will be doing specifically is, and we're working with, is we're going to be able to allow all types of different communication on the same physical wire. So you'll be able to run multiple protocols. So I don't care if it's CCLink, I don't care if it's OPC-UA, I don't care if it's Profinet, EtherCAT, Ethernet IP, they'll all be able to run on the same physical wire because of the scheduling algorithms that are actually being designed into the TSN technology. From a traffic shaping and fault tolerance view, essentially all of the devices that are participating in the TSN technology basically have to adhere to the same rules in selecting their communication paths and reserving their bandwidth and time slots. We want to guarantee that they're not utilizing more data than they're allowed. And essentially, this guarantees with traffic shaping and what we've done that we can take care of essentially having a one single simultaneous path to achieve really fault tolerance. So this allows multiple messages to be run on the wire, okay, as I said before with the scheduling, but then TSN basically will shape those messages, guaranteeing that the bandwidth that has been allocated in the time slots are actually being utilized effectively, and essentially achieving fault tolerance and guaranteeing reliable delivery between the multiple endpoints that we're working on. So when I talk about the TSN standard, right, it really defines how the Ethernet network, the commercially off-the-shelf Ethernet wire, should be time aware. TSN is not really a communications protocol, but it's really a suite of all network capabilities that can be used by any communication system. So essentially, with the TSN technology, all of the industry standards essentially will be adopting the TSN technology as part of their architecture deliberately. This allows the ability to have, again, multiple protocols running on the same physical wire, which is very, very important in the equation. Now I want to talk a little bit about CCLink IATSN and why CLPA took the TSN technology and combined it into ours, and basically took the CCLink IE technology and what's known as the SLMP protocol, which includes messaging, and the memory map architecture to incorporate all the TSN technology, forming CCLink IATSN. We announced the technology in November of 2018, and we're very excited about the number of end users and suppliers and different vendors that are actually taking and adopting the technology and bringing the TSN technology to fruition. Essentially, CCLink IATSN is really an open industrial network, essentially inheriting the easy diagnostics of all of the CCLink IE field network and the large data capacity communications of the control network, also adding the high performance motion control features of what we call SSCnet. So essentially, through the incorporation of the TSN technology, the network really further leverages the control system performance to realize a totally open integrated network with a lot of advanced functionality. So this diagram essentially shows our roadmap of what we've done with IE Control, SSC Net, and IE Field, and then rolling in TSN essentially allows us to do true 1 gigabyte and 100 megabit, supported technology. We're aggressively supporting both motion and safety communication, and really supports both a hardware and software protocol stack. And I'll be talking a lot about those stacks in a webinar that I'm doing next week with a number of the stack vendors, and you'll hear about that. So what really is CCLink IATSN? Well, our goal was to utilize the TSN technology and utilizing essentially TCP/IP and the open Ethernet networks. We can essentially mix everything on the same physical wire by using the time sharing method inside of TSN. So essentially, if you look at the current technology that's deployed right now without TSN, everything essentially has to run on, a separate physical wire for all intensive purposes. But now with the TSN technology and what we're doing, we're going to be allowing to have CCLink IATSN, a lot of other networks, TCP/IP traffic, everything on the same physical wire. So this is a big advantage to all of the end users that already have Ethernet in their factories. They're going to be able to have multiple protocols running on the same physical wire, and it will be secure, and it allows everything that we're doing in terms of scheduling and traffic shaping. What we did with CCLink IATSN and the technology essentially is all about a lot of different functionality. As I mentioned earlier, it incorporates SNLP, essentially allowing CCLink IATSN with TCP/IP messages to run on the same physical wire. But essentially, CCLink IATSN provides what I call intelligence, connectivity, and performance as part of the architecture, truly leveraging the TSN technology. I'm going to talk briefly about those different components right now. If you take a look at a lot of the intelligent networks, they allow easy maintenance and simple device setup at the same time. Maintaining the highest levels of security are really essential for competitive manufacturing operations. From time stamping, diagnostics, and setup enhancements through improved safety and security, essentially the CCLink IATSN technology, when I talk about intelligence, includes a wide array of analytics and configuration features that increase uptime and reduce time to market. And this is the basics of the technology that we've plugged in directly into the CCLink IATSN technology. Continuing on the intelligence, really the whole importance of having time stamping is basically part of TSN. This allows us all to do configuration and diagnostic setup very easily. Safety really becomes more and more important feature for automation networks, and the people are really starting to realize that a safe network improves productivity because now those users are operating in a more safe manner. You don't have downtime because of injury and, of course, security. So essentially, the IATSN technology with security will be improved over standard TCP/IP messaging because you have these time slices and arrangements for these type of messages that go on with every single item. So the technology and the intelligence that CCLink IATSN brings together, leveraging the TSN technology, gives us improved diagnostics and configuration. It gives us safety and security. In addition to that, it allows for the ability to have a lot of third-party diagnostic tools directly to be able to plug in on the physical wire and help you troubleshoot when you do have problems, and hopefully you won't. But you'll be able to use technology like Wireshark, which are diagnostic tools to access all the communications on the network, which can really provide you a lot of diagnostic capabilities. So this really is starting to move in the direction of what I'm going to talk about in the future of how we can do things in terms of both IT and OT convergence and how important the TSN technology plays into that equation. So some of the key markets that are being addressed with CCLink IATSN technology and how we've leveraged TSN goes into the markets like food and beverage. The food and beverage industry and the packaging industry really has a lot of increased demands for a lot more information about how the lines are running, doing preventative maintenance, essentially doing things with improved product safety, better traceability, and the goal really is to have a lot of higher yields per shift, and the whole concept of personalization basically can be leveraged very quickly with high-speed deterministic network that CCLink IATSN provides with the TSN technology. So I want to talk about the connectivity aspect of what we've done with CCLink IATSN. So first off, it's really about an open technology. It's following the IEEE standards. IEEE has been developing TSN. I told you it started in 2012. It's a standard Ethernet infrastructure. Most importantly, though, it's backward compatible. So essentially, you are going to be able to have all the different CCLink technology, whether it's IE Field Basic, IE Control, all these types of networks will be able to happen and be able to work on the same physical wire with the IATSN technology. I talked about standard Ethernet. It's flexible. Bound rates are on it, right? With IE Field, it's fixed, okay? With IATSN, it basically, we recognize it's a very large installed base of a lot of 100 megabyte products out there, and we want to have both backward compatibility with those products and also take the leap and move forward with other things. So, it's an open technology, it's the standard Ethernet infrastructure, and it's backwards compatible. So from a connectivity standpoint, because it's a fully open technology with a variety of different development methods from both a hardware and software perspective, it really offers freedom of choice for device vendors, and as a result, end users and OEMs really are able to benefit very significantly from the technology. Systems can be built basically around best-in-class devices, while at the same time guaranteeing multi-vendor interoperability, which is what all the end users keep clamoring for. They're tired of being locked into a single network, a single device vendor, and not being able to have other things working. Now with the technology of the IATSN and with the TSN technology, basically you're going to be able to have TCP/IP devices on a single cable. So essentially you can use general purpose Ethernet devices in communication with all of these IE products that we have from CCLink, which really allows options that the end users can select for their application installation directly. This is a very important part when you start thinking about interoperability. On top of this, ultimately, you're going to be able to integrate wireless communication. You're going to be able to talk to third-party networks and connect to an impressive range of devices that typically you can't connect to today. So essentially, IATSN offers you the key technology really to advance into all of these Industry 4.0 applications that I talked briefly about before. So another part of the industry that I'm very excited about is the whole thing of material handling, and why the technology with tight synchronization of multiple motion axes basically allows you to produce maximum web yield and machine design flexibility. So if you think about, I got time synchronization of multiple axes, I can max my yield, I've got open design flexibility, and I can really do changes in packaging and design very quickly when you start thinking about material handling application. So you were never able to do this before, okay? Previously, the network really was the bottleneck to do a lot of these type of high-speed, deterministic, high-performance application. With TSN, essentially, though, there's no need to redesign the entire network application. You can add and take out devices without massively affecting your application. You can gradually add on. This is the power of being able to use a single physical Ethernet wire and allowing multiple protocols and the ability to easily connect up devices onto the network. Everyone worries about performance, okay? And everyone worries about performance from a control perspective. And specifically what we've done between control, motion, and safety with CCLink IATSN, we're really enabling high-speed, accurate cycle times and management of really large amounts of data on the wire. This really means control, motion, and safety data all really integrates seamlessly across the same network. On top of this, TSN allows the integration of normal TCP/IP packets, enabling the integration of general traffic alongside critical process data without any loss in performance whatsoever. So essentially, it can link up with other networks and sharing data across all of your existing installations. So really, the IATSN, and the reason that I joined the CLPA organization several months ago was because I saw the power of what they were doing with CCLink IATSN, and it's the only open networking technology available today that really offers the necessary bandwidth to cope with the explosion of data that Industry 4.0 and all the regional equivalents are really bringing to the table. So again, on performance, you talk about its gigabyte bandwidth, its TCP/IP. I can do control, safety, and motion. So essentially, I mentioned earlier that you can do high speed, you can do 1 gigabyte, and when it comes to pass, because 802.1 basically moves things forward with 100 megabit, and allow eventually IATSN will manage these speeds as well. So you can go onto the general standard Ethernet platform. You can add all kinds of different messages basically with IATSN. You can put motion, you can put control, you can put safety. And we're working with a lot of major companies to bring products to market that provides the high-speed performance necessary for a variety of different applications, and to be able to leverage this on the same physical wire. Whether or not you need deterministic behavior or non-determinism, the technology can maintain all of your applications for control, motion, and safety. So in the automotive marketplace, in the work we've been doing there, the technology allows decreased cycle times along with a high capacity, what I call data handling capabilities that they really need, really improving the quality of assembly of multiple vehicle models and trim levels. So you got a very complex architecture in automotive. We want to decrease the cycle times. I want to allow model changes very easily. I want the ability to do a lot of quick speed data handling applications, and really improving the quality necessary that we find in terms of automotive types of applications. So, and everybody knows the automotive applications, and I've had the opportunity to walk with them, and they always want the best and cheapest, and they want it yesterday. With IATSN, we really believe we're ahead of everybody else. We're really ahead of the game, and we're one of the first TSN technology introduced to the market now, really allowing for control, safety, and motion. And it's going to really allow the automotive customers to give them the necessary traceability of parts of individual car. This is all the kind of components and things that the automotive industry is looking for as they're building and manufacturing their vehicle. So, they've got a lot of different manufacturing networks that they're using. We know they all use CCLink, and what they're looking for essentially is how do they get more quality data and how do they get more data out of their system. And the whole concept is, with all the switches and everything in the network, we're going to be able to allow this to run on the same single physical Ethernet wire, really allowing the capability of doing, what I've talked about with all these different applications, and specifically really helping out the automotive market. So with Mitsubishi, I also work for them. They're basically developing products really to support the latest industrial network technology. They've been a very strong proponent and really pushing CCLink for a long period of time. Now they're pushing CCLink IATSN as part of their core architecture, along with supporting all of the other industrial networks. And bringing all this thing together is the whole concept of what Mitsubishi trying to do. Mitsubishi wants to be the best vendor that really allows all the applications like food and beverage, material handling, automotive, and a variety of other industries to really take advantage of the TSN technology in a very proactive fashion. So from an industrial networking perspective, essentially Mitsubishi again supports a wide variety of networks to meet the needs of any application at all levels of the network hierarchy. They're very actively engaged in a lot of things like the eFactory Alliance, EdgeCross, and essentially being very active into the Industry 4.0 architecture, really allowing data and information integration from the factory floor up into the enterprise. So, they support obviously all the CCLink technology. We also support all the things in the Profinet and Profibus world, Ethernet IP, EtherCAT, Modbus, and DeviceNet. All this technology all comes together, and many of these technologies ultimately will be running on the same physical wire with the TSN technology. Goal of Mitsubishi basically is to have connectivity and full seamless integration and leveraging IATSN as part of their key architecture. If I take a look at what CCLink IE is, it's an open network. We talk about seamless data communication from the factory floor all the way up to the top. And really, it's about data and information integration. So the CCLink IE is an open protocol managed by CLPA, CCLink Partner Association. And CCLink IE comes in two flavors, the traditional CAN bus-like network, known as CCLink, and then the Ethernet version, which is known as CCLink IE. And you see how those come together with CCLink IE field and where it's positioned. CCLink IE control is on the second level of the pyramid, and essentially it starts doing distributed control. At the IE field level, it's all about safety and motion and IO control. It's distributed control at the next level up, and essentially with the Ethernet and what we're doing, we're pushing a lot of data up there. So if you look at the performance aspects at the field level, it's high-speed performance you really need. As you move up the pyramid, it starts to decrease in terms of the real-time performance capability. But we see is that the amount of data you're pushing, when you start thinking at the high-level part of the network, the data and information is a lot higher. Why did Mitsubishi basically leverage and take advantage of CCLink IATSN? Because they wanted high-speed performance, they wanted the ability to have master-to-master and slave-to-slave communication between devices. They knew TSN provided this whole concept of high-speed synchronized data exchange between all the devices on the network, and with the technology, you can really have over 60,000 devices connected with a maximum of 4 gigabytes per station. So if you need to do motion, you want to do safety, and you want it to be a standard, and you want it all in one network, the TSN technology and how CCLink has adopted it and Mitsubishi has adopted it really comes together with a complete solution for IT to OT convergence. The other part of the thing is that Mitsubishi recognized was connectivity. Everything is going Ethernet, right? And you want to basically be able to mix a lot of other standard Ethernet-based devices all in the same physical wire. So when people talk about the Internet of Things and the industrial Internet of Things, you think about the data analytics and all the different things that we have. Mitsubishi's acquired several companies, including Iconics, and they've basically brand labeled the MC Works as their software solution. And all this comes together from a connectivity perspective, really enabling and handling and processing large amounts of data and using analytics essentially to push that data and migrate that data into useful information as it goes up the pyramid. So essentially Mitsubishi supporting TSN really provides a connectivity that the process and discrete market are demanding, and allowing all these multiple devices on multiple networks to all operate seamlessly. This is what excites me about this every day I breathe. So I talked earlier about intelligence. We've basically integrated the intelligence component directly into the Mitsubishi devices, both the safe and non-safe devices. We've provided a lot of advanced network diagnostics capability with time stamping and synchronization. And essentially, it's very quick and easy setup, similar and prior to what we've done with CCLink in the past. So we learned a lot from the technology that we deployed with IE Field and IE Control, and we basically migrated and put all those advanced intelligent features directly into the Mitsubishi devices, leveraging IATSN as the core component of the architecture. From a goal strategy perspective, if you take a look at all the Mitsubishi devices and everything we've done, we've got IATSN, you got your HMIs, you got your remote I/O, you got standard remote I/O, you got your servos, inverters, and robots, right? And essentially all these now are seamlessly connected with the CCLink IATSN technology. And so again, if you think about the connectivity, you think about the performance, you think about the intelligence, right? And you think about the high-speed deterministic operation that TSN brings to the table, we really can allow all these different applications and devices to be able to seamlessly talk together. And this is a big advantage of leveraging the IATSN technology. So some of the products that we've introduced in terms of masters and remote I/O, this is a couple of the products that Mitsubishi released in December of 2019 that has IATSN into the technology. So you'll find their switches, you'll find their PLCs, you'll find their robots, you'll find their all of the devices deliberately supporting the technology. My slides will be available and you'll get a copy of all these. This is kind of some of the different I/O modules that they've released, and I'm not going to go through every one of these, but that's the basis of that. And again, so our product lineup of what we've done, this is kind of the different feature functionality that we know is important. So we talk about the different applications and which application should leverage IE Control, IE Field, or IATSN. And this is kind of the matrix that you can take a look at. But the key thing is, all of these technologies will be able to run on the same physical wire, particularly if it's IE Field and it's IATSN. Essentially, they'll be able to run on Ethernet deliberately. So this is the architecture of what we've pushed together. And again, it's all about having complete compatibility, high-speed control communication, and seamless communication between your IT systems and the shop floor. So from a configuration standpoint, you can basically have both a line and star topology supported, really ensuring ideal system communication for production. You'll use line topology for high-speed, high-performance control, or use a star topology if you've got a more flexible system configuration is needed. So depending on the Ethernet switch specifications, slave devices can easily be distributed to achieve what I call the desired system configuration. So we're available to help you on a lot of these different applications to make this work. This is kind of the setup application that you take a look at that allows you really to detect and start being able to configure the different TSN devices. And we basically build this as a standard configuration application that is distributed as part of the architecture of what we're pushing out. So what's the next steps? I covered a lot of material very quickly, and I apologize for that. We had a couple little glitches in the beginning, but essentially I want you to discover and take a look at what I consider the game-changing technology of TSN. Really, your end users, if you're an end user, you guys want to start thinking about the smart factory and really how you have all this connectivity and how you get all the data and be able to turn this data into useful information. You need to assess a lot of your current OT networks and your different suppliers, right? I want you to take a look at what we've done with IATSN. And ultimately, you're going to be in this world where you got to think about your convergence and connecting IT to OT. If you're in the OT world, the IT guys are breathing down your neck. If you're in the IT world, you know what you want. You want the data from these guys, and you want to have the ability to operate in a safe fashion. So check out what CLPA and Mitsubishi really is providing to make the smart factory dream really a reality. And again, we encourage you to take a look at all the technology. For more information about anything we talked about, please don't hesitate to contact me, check out our website, or contact Mariana to learn more about what we've done with CLPA, and why TSN is such an exciting technology, really enabling the smart factory. So thank you very much for your time. Thank you for taking time out from your busy day. A question came out about how does people guarantee that the technology as a standard is being validated? We have a lab. We do certification and competency testing on all products. So we will guarantee that all CCLink products, and particularly CCLink IATSN, are certified, right? Does CCLink IATSN require anything beyond IEEE 802, such as cut-through switching? It does not require anything, but what we're going to do is we're going to keep taking advantage of, new changes that come out, particular areas of like doing cut-through switching, and take advantage of a lot of the new configuration features and, essentially how we configure the multiple protocols running on the same physical wire. The timing accuracy between stations, a lot depends on, what devices you have and how these devices are configured. But the simple answer really is that whatever you configure will be, and the tolerance is part of being deterministic with TSN. So the exact timing accuracy between stations, right, it's going to be in the microsecond granularity is what our plans are. So we've got another series of webinars that are going to go on. Next week's webinar is going to be focused at, really how you adopt the technology and bringing together some of the vendors that have been doing stacks for CCLink IATSN. Our plan is that CCLink basically is the technology that you can easily connect up to a lot of all these different devices. I'm currently working with a lot of different vendors where we'll develop bridges between multiple industrial networks. So you'll have a converter between Profinet and IATSN technology. So with that, I'm going to end our presentation today. Again, I thank you very much for taking time out, and please do not hesitate to contact us, and we really appreciate your time.